All right, guys, so you have your note sheets out. Calculator, something to write with. We're getting started. We're getting started with the note sheet. All right, guys, so where we finished off, where we stopped off yesterday, I believe it was this problem here. We did not finish this one yet. And as we've seen with most of these here, a good place to start with solving these higher degree polynomial equations is to graph them. So the first thing we'll want to do is get the graphing calculator and hit y equals. All right, guys, focus in here. So we have 6x to the fourth minus 11x cubed minus 16x squared plus 2x plus 4. So we want to type the entire equation in and then hit graph. Now what we're wanting to do is we're wanting to find the values of x that will make this function equal 0. Now it does cross the x-axis. It looks like it intersects the axis in 3 or 4 spots. So we have these spots here. And even if we look at the table, there is not a nice integer solution where it crosses the graph. So that means we are going to have to use our rational zeros theorem. We're going to have to find all the rational zeros and use those to find enough solutions to be able to solve or get it down to a degree 2. Now, P is the factors of the constant term, and Q is the factors of the leading coefficient. So our constant term, in this case, is 4. Q is our constant term. So the factors of 4, the numbers that multiply together to get 4, well, we have 1 and 4 or 2 and 2. Now, even though 2 is a factor twice, we're only going to write it once. Because any repeated factors for this here, we don't list multiple times. We're just going to list it one time. Now, the factors of the leading coefficient, we're looking for the factors of 6, which is 1 and 6, or 2 and 3. So for this one here, we do have more factors for the leading coefficient than constant term, and that is perfectly fine. Questions on how we found the factors of P, our numbers for P and the numbers for Q. Now we're going to start our plus or minus P over Q. I always start with the first value of Q, which is always going to be 1, and divide every P by it. So we're going to do 1 divided by 1, which is 1. 2 divided by 1 is 2, and then 4 divided by 1 is 4. Now we're going to divide everything by 2, so we'd have 1 over 2. Doesn't reduce, telling us that we have plus or minus 1/2. Now 2 divided by 2 is 1. And 4 divided by 2 is 2. So those two are already listed. We don't have to write them again. Then we would go on to 3. 1 divided by 3 is going to give us plus or minus 1/3. It's not listed and it doesn't reduce. 2 over 3 is going to give us 2/3. And lastly, 4 divided by 3 would give us 4/3. We have to do this one more time. We need to do it with 6. So we'd start off with 1 over 6, which is 1/6. Now 2 over 6 is going to reduce because they do have a common factor of 2. 2/6 is going to reduce to 1/3. We already have 1/3. 4 over 6 would reduce to 2/3. It's already listed. So really our last term is plus or minus 1/6. So we have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 1/2, 1/3, 2/3, 4/3, and 1/6. And as we look back at the graph, if we look back at the graph, positive 1, negative 1, positive 2, negative 2, and positive 4 and negative 4 are not solutions. They do not show up on the graph. They do not work. So we can remove those already. Now we can try 1/2. Now a good way to type this in or check it is our value. Using the value function in the graphing calculator. To get that, we got to go second trace value. Second trace value. And the first value we can try is 1/2. And as long as that gives us a y value of 0, that is part of the solution. And well, actually it tells us when x is 0.5, the y value is 0. So that is helpful because it is telling me that x, one of the solutions, is indeed 1/2. So we found one. We need to find at least one more. So we can try negative 1/2 next. Well, when x is negative 1/2, the y value is 0.75. Our next value in the sequence is 1/3. When x is 1/3, the y value is not 0. Then we can move on to negative 1/3. Still does not give us a y value of 0. Positive 2/3 does not give us a y value of 0. Negative 2/3 does give us a y value of 0. So negative 2/3 is our next solution. Since we're almost there, we can try 4/3. Doesn't work. Negative 4/3 also does not work. 1/6 doesn't work, and negative 1/6 does not work. So the only two rational zeros that we have is 1/2 and negative 2/3. So we needed at least two rational zeros for us to be able to solve for the rest. That's the minimum number we needed. And since we have those two, we can use synthetic division to find the rest. So we can start off with 1/2. Now we're doing synthetic division. One thing to keep in mind is if there is a term missing, we have to fill it in as 0. And this here we have the fourth, x to the fourth, x to the third, x squared, x in our constant term. So we don't have to fill any in as 0 here. But once we get that started, we can go on and start our synthetic division. Now our 1/2 times 6 is going to be 3. Positive 1/2 times positive 6 is positive 3. We put it above the line, below our negative 11. Then we're going to add our negative 11 and 3. Negative 11 plus 3 is going to give us negative 8. 1/2 times negative 8 is negative 4. Now we're going to add negative 16 and negative 4 together. Negative 16 plus negative 4 is negative 20. 1/2 times negative 20 is going to give us negative 10. Add those two together. 2 plus negative 10 is going to be negative 8. 1/2 times our negative 8 is negative 4. And 4 plus negative 4 is indeed 0. Any questions on the first synthetic division before we start the second one? Our second one, we're going to use negative 2/3. So we're doing the same thing. And again, if it's going to be helpful for you to use a calculator, either one to do this addition and multiplication, use it. There's nothing wrong with it. Because negative 2/3 times 6 is going to give us negative 4. Then we're going to add these two together. Negative 8 plus negative 4 is negative 12. Negative 2/3 times negative 12, the negative and negative make a positive. And 2/3 times 12 is going to give us 8. negative 12, or not negative 12, negative 20 plus 8 is negative 12. Negative 2/3 times negative 12, we already know is going to be positive 8. And negative 8 plus 8 is 0. So we've used the two solutions that we have. We don't have any left. So what we need to do is put the variables back in, set that expression equal to 0, and solve. So this is going to be our remainder. Our negative 12 is our term with x. 6 is our term with x squared. Telling us that the quadratic equation that we have left to solve is 6x squared minus 12x minus 12. Now, because we do have a middle term, we do have that x to the first power, it means that we can't use the square root method. So if we didn't have that x middle term, we could use the square root method. It is a lot nicer than the completing the square or the quadratic formula. But at this point here, we can use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. At this point here, we just need to plug the values of a, b, and c into their respective places. Now the a value, a is the number in front of x squared. So the two places a shows up, one is inside the radical and the other is on the bottom of the fraction, so we'd fill 6 into both of those places. The next is our b term. It's the number in front of x. Now we do take the negative with it, so b is negative 12. So we plug negative 12 into the two places where b shows up, here and here. And lastly, c is our term without x. It's our constant term. It shows up only in one spot, right next to the 4ac. Questions on how we plugged in a, b, c? Now we need to simplify. There's a few things we can simplify pretty nicely. Our negative, negative 12. The negative and negative is going to make positive. On bottom, 2 times 6 is 12. Now at this point here, I would simplify everything inside the radical. Our negative 12 squared minus 4 times 6 times negative 12. I'd pick one of the two calculators, either the 30xs or the graphing calculator, and type everything inside the radical. I wouldn't type the radical, but everything inside it into the calculator first. And it'll tell us that negative 12 squared minus 4 times 6 times negative 12 is 432. Now we do need to see if the square root of 432 simplifies. One of the ways that we can do that is we can type it in the graphing calculator, and it tells us that it's 20.7846096.9. So that might mean that it doesn't simplify, but the graphing calculator doesn't leave it in simplest radical terms anyways. I would rather use the 30xs, the yellow calculator. It will simplify radicals as long as the numbers don't get too big. And it does tell us that the square root of 432 simplifies to 12 square roots of 3. So since that does simplify, we do need to simplify it. Telling us that x equals 12 plus or minus 12 square roots of 3 all over 12. And we're done as long as there's not a number in common with the two terms on top and the one on bottom. Unfortunately, there is. All three spots are divisible by what? 12, isn't it? All three have 12 in it. So we can actually reduce that 12 out. We're going to divide everything by 12, or really one way we can look at it is 12 plus or minus 12 square roots of 3 over 12. Those 12s are going to reduce out completely. Because since the term in common in all three is just 12, the 12 on bottom is going to become 1. The two 12s on top are also going to become 1, leaving us with 1 plus or minus square root of 3. Does that kind of make sense? Because we've gone over different ways to simplify that radical or that fractional answer. This is one of them. We split it up into the two parts and reduce. This makes it a little bit nicer because we're looking at 12 12ths, which is 1. 12 square roots of 3 over 12. The 12 over 12 reduces to 1. We get this here. So the other two solutions is 1 plus this or minus the square root of 3. And the plus or minus gives us a way to write two solutions as 1, so we don't have to write 1 minus the square root of 3 and 1 plus the square root of 3. We don't have both listed. Questions on this here? We're ready for the next one. So we want to find all the real solutions for x cubed minus 5x squared minus 2x plus 24. Now with this here, again, as I've said before, we want to find at least n minus 2 solutions where n to the degree. So n minus 2, we need to find at least 1, because if we find 1, we can bring it down to a quadratic. If we find 2, that's even better, because that's going to take it from a quadratic degree 3 down to degree 1, a linear. Or the best case is if we can find 3. So if we grab the graphing calculator and type this in, x cubed minus 5x squared minus 2x plus 24. We type it in and hit graph. This actually has 3 nice zeros, -2, 3, and 4. We needed at least 1. We did get more than 1. We actually got 3. Since it is a cubic, we need 3 solutions. We have 3 solutions, yes? Are there going to be any more? Couldn't be. That's it. We are done. Graphing calculator told them all to us. We could do synthetic division to verify, but we don't need to. We have everything. We're moving on. So really what it's looking like is we just, especially with solving, throw it straight in the graphing calculator. Let it do most of the work for us. Especially for this next one, 3x to the 4th minus 2x cubed minus 37x squared plus 24x plus 12. We're going to put it in and graph it. Since it is a degree 4, we need at least 2 solutions. Because if we have 2 solutions, we can use synthetic division to get it down to a quadratic. If we get 3, we can get it down to a linear. If we get 4, we are done. But as we look at this here, well, it only looks like it really crosses at one point, one integer value nicely. And that integer value is 1. So that is nice. And that x is indeed equal to 1, but we need more than 1 value. We need 2. So we're going to have to default back to the rational zeros. Because if it gives us 2, we don't even have to look at the rational zeros. We can just use those solutions and move on. If it doesn't give us enough values there, we're going to have to default to this here, where p is the factors of the constant term. And the constant term in this case is 12. So our numbers that multiply to give us 12 are 1 and 12, 2 and 6, 3, and 4. Factors of the leading coefficient. The factors of 3. So we have 1 and 3. Plus or minus P over Q. Well, the first number, value of Q, I would divide all the values of P by. I just use 1. Because to save error and a lot of unnecessary talking, we're just going to get the numbers, the values of P, the factors of 12 back out when we divide each one by 1. Really doesn't change anything. Well, the other value we need to divide it by is 3. 1 over 3, we're going to get back. It's still going to be 1/3. 2 over 3 is going to be 2/3. It doesn't reduce, we don't have it already. 3 over 3 is 1, we have it. Next one would be 4 over 3, it doesn't reduce, we don't have it, so we do need 4/3. Hopefully we don't have any more because I'm running out of room. 6 over 3 is what? 2, we have it. 6, or 3, let's see here, where am I going? 12 over 3. 4, we already have it. So those are fine. Now we do have a good number of solutions here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 18 with the positive negative. We already confirmed positive 1 works, but it didn't intersect on the graphing calculator. The graphing calculator did not show me crossing at -1. So that's one solution out. 2 and -2, 3 and -3, 4 and -4, 6 and -6, 12 and -12. None of those worked because it did not cross at any of those values. Now, specifically, when we looked at the graph, we actually didn't look at 12 or -12. Because again, the standard on the graph is from -10 to 10. But it did show us that the graph crossed the x-axis at 4 places. Where it crosses through, as I said before, it's an odd multiplicity. There's an odd number of zeros there. We're looking for, and most likely, quartic is going to have 4 zeros. I have 4 intersections, so each one of those should have a multiplicity of 1. 1 0 there. And if I have 4 places that it's crossing between -10 and 10, is it going to cross outside of there? No, because all 4 are right there. So do I need to look at 12 and -12? No, because it's not going to cross out there. So now we're left with positive, negative, 1/3, 2/3, and 4/3. Yes? Well, as we look at the graph, the 1, this spot right here, we already have, yes? Now, the other solutions we have 1 way out here, and we have 1 right there. The 1 out to the far left looks like it's between -3 and -4, and the 1 on the far right is between 3 and 4, yes? Which one of our remaining rational zeros is between -3 and -4, or 3 and 4? 4/3 is what? 1 and 1/3, yes? Well, that's none of these are near those 2 spots, are they? No, they're too far away. So those 2 are not rational zeros. They're going to most likely be irrational. They're not complex. Complex does not cross the x-axis. So we have those 2 as irrational zeros. We can try to throw those out. Because what we're doing is looking at them and seeing what's the most likely answer. So as I look at this here, those 2 are gone. Because they can't be any of the rest of our rational zeros. The only one that's left is what? This one right here, yes? Is that going to be a positive or negative value? Negative, because it's on the left side of the y-axis. So it's like, why do I bring this up? Well, that means positive 1/3, positive 2/3, and positive 4/3 are now. That is 3 less values I have to check. Just by graphing it, we took out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 values. we didn't have to check. Even with the value, we don't even look up. So now we just need to look at negative 1/3, negative 2/3, and negative 4/3. Second trace value. Negative 1/3 is 0, yes? Do I even need to look at negative 2/3 or negative 4/3? No, because we know those other values are not going to hit the last two spots. They're just too small. One or negative 1/3, which one do y'all want to use first? Doesn't matter. 1, 3. One is a nice one to start with. The only one nicer to start with for a solution is 0. Now 1 times 3 is 3. Negative 2 plus 3 is 1. 1 times 1 is 1. Negative 37 plus 1 is negative 36. 1 times negative 36 as well, negative 36. 24 plus negative 36 is negative 12. 1 times negative 12 is negative 12, and negative 12 plus negative 12, or 12 plus negative 12 is 0, just like we wanted, yes? All right. Now we're going to have to use negative 1/3. Negative 1/3 times 3 is actually negative 1. 1 plus negative 1 is 0. Negative 1/3 times 0 is 0. Negative 36 plus 0 is negative 36. Negative 1/3 times negative 36, it's going to be positive 12. And 12 plus negative 12 is 0. Now we fill the variables back in once we get to this point. 36 is going to be our constant term, our term without x. And 3 is going to be our term with x squared. I skipped over it, but the 0 is our term with x. Now this one here is our final expression, and we do want to see what value of x makes it equal 0. These are the ones I like. I like these a little bit better than our one that we had on the previous one, because it doesn't have a middle term. And the big advantage for solving this here, because it doesn't have the middle term, we can use the square root method. Square root method is very nice, because all we got to do is get x squared by itself, take the square to both sides, and we're done. So here, we add 36 to both sides. And negative 36 plus 36 is indeed 0, and 0 plus 36 is 36. Now again, to get x squared by itself, we're going to have to divide both sides by 3. 36 divided by 3 is 12, yes? And last, we have to take the square root of 12. Now the square root of x squared is just x. Remember, whenever we take the square root of both sides, we have to put the plus or minus. Can we take the square root of 12 nicely? No. What can simplify our square root of 12? 30xs tells us it's 2 square roots of, those are our other two solutions. That's why it didn't come out, or isn't a part of our rational zeros, our plus or minus p over q, because 2 square roots of 3 is not rational. Questions on this here? Questions on anything we've done so far? hopefully, because I think y'all are starting to see how helpful with solving these in that graphing calculator are, because the graphing calculator can give us a big step towards finding all the solutions. Last thing we're going to talk about in 2.5 or 4.5 is the irrational conjugates theorem. We've talked about the complex conjugates theorem, and I always say complex conjugate for both, but the irrational conjugate theorem is pretty much the same thing. It says that if a plus the square root of b is a solution, then a minus the square root of b has to be a solution also. If we get one, we have to have the other. If I have, so like the last one, I had 2 square roots of 3 as a solution, negative 2 square roots of 3 is a solution. If we have one, we have to have the other. And especially if you're planning on taking college algebra or upper level math, they will give you these higher degree polynomials and pretty much tell you it's a degree 4 like we just had. By the way, one of the solutions is 1 plus the square root of 3. So since we know that's true, we know 1 minus the square root of 3 is a solution. It gives us the 2, then we have to go find the other 2, and they're most likely irrational solutions or complex solutions or a number that is actually a irrationally complex number. We have radicals and I. So it gives us a way to start. But what we're going to do is we're going to kind of work backwards. The last 2 that we're doing is working backwards. I think of it as going backwards. Because up to this point, what we've been doing in most of this section is that we've been solving. So they gave us the polynomial, we found the solutions. This time, they told us that the solutions, the zeros, is 3 and 2 plus the square root of 5. They want us to find the polynomial that has these solutions. So what I know is that x is 3, because that's a solution, that's a 0. We also know that x is 2 plus the square root of 5. That's all a 0 is. When we talk about zeros, we're talking about a value of x that will make the equation be 0. But also, so we do have these 2, but according to the last theorem we had, if a plus the square root of b is a solution, then a minus the square root of b has to be a solution. If we have one, then we have to have the other. Questions on this so far? So when we went through and did factoring, we solved it by factoring. First thing we did was pull out greatest common factors. Factored it, we had multiple sets of parentheses being multiplied together. Set those things equal to 0 and solve. Yes? So since we're going backwards, well, we're already at the solve step. So let's get them equal to 0. So for the x equals 3, I'm going to minus 3 from both sides, because those would cancel, telling me that x minus 3 is equal to 0. Really, we're just trying to get them back into a factored form, or the factors. We're trying to find the factors. Now, for our x equals 2 plus the square root of 5, well, I'm going to minus 2 from both sides. Tell me x minus 2 is equal to the square root of 5. Then at this point here, we're going to subtract the square root of 5 from both sides, telling me that x minus 2 minus the square root of 5 is equal to 0, so now it's in factored form. You all have a guess of what the other one's going to finish out being? X minus 2 plus the square root of 5, because the only difference between the two is the sign in front of the radical. We don't have to just jump there, because what we can do first is we can subtract 2. Telling us x minus 2 is equal to negative square root of 5. Then we would have to add square root of 5 to both sides. Telling us that x minus 2 plus the square root of 5. Because if we're given a plus b, a plus square root of b, we have to have a minus square root of b. We're switching the sign in front of that radical. Questions on this here? Well, to get to this point, we had them multiply together, yes? Now, we don't care about it equals 0 because we're not solving. We're just trying to get the equation. We set them equal to x and then get them equal to 0 so that we can get the factored form, or the factors of this polynomial, which was x minus 3, x minus 2 plus the square root of 5, and x minus 2 minus the square root of 5. Now, we need to multiply these together. Now, it is perfectly logical. We can do it. We can say x minus 3 times our x minus 2 minus the square root of 5. I would not do that. At this point, I would multiply our conjugates together, either complex conjugate or irrational conjugates together first. Always do the conjugates first. And it's not wrong not to, it just gives us way too many terms. Because here, x times x is x squared. X times negative 2 is negative 2x. X times the square root of 5 is plus x square root of 5. Negative 2, we're going to do the same thing. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Negative 2 times the square root of 5 is negative 2 square roots of 5. And then lastly, we're going to do this with negative square root of 5. Negative square root of 5 times x is going to be negative x square roots of 5. Negative square root of 5 times negative 2 is negative 2, or positive 2 square roots of 5. Green. Now, lastly, we have negative square root of 5 times square root of 5. Well, our negative times the positive is going to be a negative. Now, up to this point, we haven't been multiplying inside that square root because they're not the same radical. We can only multiply what's inside if the radicals are the same. So square root of 5 times square root of 5, this works. 5 times 5 is 25. What's the square root of 25? So I could write this as the square root of 25, but that's just going to be 5. Or we can say square root of 5 times square root of 5 is the square root of 5 squared because it's multiplied by itself. But a square root and square would cancel, telling us it's just 5. Okay? Now, I did say a minute ago we want to multiply the complex conjugates together first because we're going to have less terms. We don't have less, it doesn't look like we have less terms. But if we actually look at this, I'm going to look at two terms specifically before we start condensing. X squared of 5 and negative x squared of 5. Those are the same terms. One's positive, one's negative, yes? So when I combine those like terms, we're going to get what? 0, because it's just 1 plus negative 1. Okay, those are gone. How about, okay, I think, where is it supposed to be? It's supposed to be right there. Because I think when I backed up to try to get that look nicer. Yep. Yeah, I was like, I lost this term because our 2 square roots of 5 and negative 2 square roots of 5 also cancel each other out. This is why I say to do the conjugates first, because even though we do get all these radical terms, they all simplify each other out. They're gone. And really all that we have left, one, our x squared term is just x squared. There are no other like terms with it. Negative 2x minus 2x is negative 4x. 4 minus 5 is minus 1. So even though we started out with two trinomials that were multiplying together, we ended up with a trinomial. We didn't get something bigger. Most of the time we get something bigger. And the reason that worked is because they were complex, or they're irrational conjugates, all the radicals simplified out, it simplified down. If we multiplied it with that x minus 3, we would still have those radical terms, and then we've got to multiply that whole expression by the other one before they'll simplify. But last thing we got to do is just distribute x minus 3. X times x squared is x cubed. X times negative 4x is negative 4x squared. x times negative 1 is negative x. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 4x is plus 12x. Negative 3 times negative 1 plus 3. Lastly, we're going to combine like terms. X cubed doesn't have any like terms. Negative 4x squared, negative 3x squared give us negative 7x squared. Negative x plus 12x is plus 11x. And our constant term of 3 doesn't have any like terms, so that is it there. Questions on this here? And really, we could have more complex ones of these, but it's just the numbers look funkier. It's just bigger numbers. But that is it of 4-5. We have 4-6, which we're going to start tomorrow. We're going to do tomorrow. And then we are done with Chapter 4. Your Chapter 4 test is going to be next week. And all of your assignments have to be turned in, well, for the end of the semester, which is a week from Friday.